no, it's not going to talk here. Hold on. Yes, ma'am. Yes.
What about like, have you ever seen like glow in the dark stuff? Like shadows?
Yeah, glow in the dark actually re-emits light. So you can, if you shine a light on something, the electrons are going to pop back out, right? They're going to pop out, and then they're going to re-glow. Now, most things don't glow very much when they're excited. When the electrons are out there, they don't fall in instantly. If you have something that's glow in the dark, what's happening there is you made a chemical reaction, and those chemicals are attached to each other. You've stepped up all their electrons. And so what happens is they start falling back in, and what you're seeing is the glow from that. Okay. Now, other times there's single colored, so what you have to do is they put a tube on the outside, which changes the color so it becomes a more general color. But yes, glow in the dark actually is things re-emitting the light. Okay, those are electrons falling back in. That's why they work as long as the chemicals work. Now, again, some of the phosphorescence is a chemical reaction. When you put two chemicals together, they'll start glowing in the dark, and that's because electrons are getting really excited because of the energy of the chemical reaction. And then as the electrons start to fall back in, you're seeing the glowing from that. Does that make sense? Is that okay? Did I do good enough by that? Okay. Now, again, if you mean neon, that's not the same thing at all. I actually don't. If you ask me about neon, I'll be like, I'm a little nervous saying what's happening there because I don't really know. I think your eyeballs just see it differently. I'm not sure why neon. I should look that up. Get myself in trouble. Okay, so right here I have a diagram. The diagram is saying the following because it's not inherently obvious what these Bohr diagrams look like. Let's see here. Go, and. Okay, let's do this one. What it means is that what this diagram I intend it to mean is that if you go from here to here, you get from this shell. This is the nucleus, by the way. There's the nucleus. What I mean is to get from this shell out to this shell. Are you with me? I spent a lot of time to explain something that. Okay. If I want to get from this shell to this shell, it requires a purple colored light. A specific one. I'm going to use the word purple, but what you mean is one of those little tiny lines at exactly the right frequency. Yeah? If I want to get from this shell to this shell, I would need to jump up a red. Does that make sense? If I absorb it, I can go out. If I re-emit it, if I make red light, I'm going to fall back in. Does that make sense? Okay. All right, last but not least are our fun-filled festival of fun is the shade of blue. And from here, I got this little bit of fun. All right. What are the black dots? These black dots are my friends, the electrons. I'm going to change them to yellow. I've got one here, one here, one here, one here, and one here. Everybody with me? Okay. Yes, sir.
Is that why the red and blue make purple?
No. Although, again, that's my fault. That's probably my brain did. It's not supposed to be that way. It's not. It's not. Now, purple's more energetic than red or blue, which is why it's the long one. Do I make a red and a yellow? That's exact red and blue. That's exactly the wrong thing. I gotta fix this worksheet at some point. It's older than you are, so that's not gonna happen anytime soon, I imagine. All right, so I am now going to shine a purple light on this atom. It's minding its own business, but I get the exact right frequency. I use a big purple that has all the different colors in it. And I shine it on this poor atom. Mr. Stafford, what happens? It adds energy. If they hits an electron, the electron is going to make a decision. Now this electron here goes, boom, I can have this energy. All right, I got it. But can I do anything with a purple? I can do something with a blue. Can I do anything with a purple? I can't. So what I do is useless to me. Give me that purple. Don't care. Can't jump. Can't jump. That's what's weird about this. There's only 5 different ways they can jump. Because they're not allowed to jump halfway between, is what that means. You're either in this shell or you're in this shell. You're never in between. And those of you who want a deep and profound thought, think about that for the next week. You can never be in between those two shells. That is one of those moments where your brain starts to explode and you become a scientist and you have a lot of fun saying stuff that nobody believes is true. Yeah? But we're not going to go there because we're chemists in this high school. We're literally. Okay? But what happens if this guy gets a purple? it will go from this shell all the way out to where? It'll go out the outer shell, right? It'll go like this and be right here. Because if it gets hit with a purple light, it's going to bounce out, right? And so that would be absorbing the purple. Now I have no other electrons that can do that, so nothing else happens. What about this guy? Can't do that purple. So it doesn't do anything purple, which is weird. But it tells us a lot about these shells things. Okay, move forward. What if it emits a blue light? What does that mean? What if I see a blue light? What does that tell me happens? Well, first of all, if it emits, what's it doing? No. Emit means I'm shining a light. If I'm dumping light, that means I'm losing that energy, right? What would that mean happens here? It's going to fall in. Is that okay? Pete's got you with me? Which one's going to fall in?
The electron.
Which electron?
The outside one.
Why the outside one?
Will go in.
Because blue gets you from the third shell back down to the second shell. And so this one right here, we go from here down to here. And so when I'm all the way done, I'd have 0 on the first shell. I'd have 1, 2, 3, 4, 5 on the second shell, and none on the third shell. Why? Because purple bounced the one that was the inside all the way out, and then falls back in. Now, for purposes of this class, we're going to assume the following. 1, if I shine a light, it's going to be a bright light with lots and lots of photons. So everything that can move will move. We're going to assume for this classroom. Okay? We have no way to make a single photon hit a single electron. That doesn't happen in real life. In real life, you turn on a bright purple light, and all of them are going to pop out. That's just what's going to happen. But when they emit light, they emit it 1 photon at a time, and that can actually be perceived. And that 1 photon bouncing inwards could be detected. Does that make sense? So we're going to assume you can emit 1 photon. We're going to assume when you shine a light, it's just going to blow everything outwards. Does that make sense? So far, so good. Everybody with us? Ms. Younger, you good? All right. Well, let's try number 2 since we have some time. Let's try number 2. Okay, I got to undo this.